CPU socket replacement is what truly separates men from the boys, or more professional and more hobbyist repair shops. Hello friends, welcome back to the bench. Our patient today is a MSI board. Was it MSI actually? What is it? It doesn't really matter. It's Gigabyte actually, Z370. The socket in question is 1151. Makes no difference. All the sockets are pretty much the same. How they built is slightly different and perhaps pin out because different CPUs and stuff like that. But every socket is basically in BGA. And to replace a BGA, you need stable and well spread temperature. Now, few pointers that I can give you if you want to attempt replacing the socket. And I can't really give you a tool that you can use to achieve good results because the tools that I use, as you can see, is a soda can, cheap $50 Amazon Hodder station, right? So and the microscope stand to hold it, because it's kind of important to be able to lift it and lower it in the same spot, because multiple times you have to lift it and see if it's already melted. If not, you put it back down. But the important part is that the more time you put into it, the better results you'll get. The better tools you put into it, the better results you'll get. However, always remember that your most expensive and your most important tool is here. So don't think that you can buy an expensive tool and be successful at it. To get this to this point, right, this is fully prepped socket or board, right? As you can see, there are no ripped pads. There is no warping on the board anywhere. So the board has not been overheated. Not to mention there are no exploded caps. None of the caps inside are shifted or moved. This is also kind of difficult to do, to lift the socket, because everything is hot and it's not comfortable to lift. I see other people using two sets of tweezers, and lift it from two sides. I use a single one. It works just as well. You just need to not drop the socket back on the board and not push the caps. As far as the temperatures that I got, it's not going to give you too much, but the bottom heater heats up to 260 degrees. However, I do it in cycles. First I heat it to 150, 130, 150. Then I go to 200, to 20. And then when I'm finally ready to turn on the top heater, I switch it to 260. That brings the board to about the temperature of 140, 150. Maybe 160. It's difficult to measure it after you turn on the nozzle from the top. The nozzle from the top, the temperature I use is 260 degrees, 266 degrees to be exact. And as you can see, there is no melting of the socket, right? So this is kind of a sweet spot. It's okay if you melt the socket slightly when you remove it, because you remove that socket, but you cannot melt it when you solder the socket back on. If you do, the socket might not sit correctly. It might shift, or it might lose its desired position. Now, there should be no smoke when you work on it, and you don't use flax, which I don't. I use flax to clean it, but not during the desoldering. If there's smoke coming, it's too hot. However, with this one, as you can see, there's no melting, but some smoke did come. But it didn't smell like melted plastic. So what I'm thinking is just some gunk, maybe residue from flux, maybe something, maybe just some dirt on the socket, because the board was slightly dirty. But my main point is that you don't want to see the smoke coming from the board. After replacement or after removal of the socket, it's very important to clean the pads. And the way you know that they are clean, or the way I do it, is I just rub my finger across the board and I feel if there's anything catching my finger. If there is, and anywhere, any pad that is catching your finger, you have to work a little harder to remove the solder. To remove the solder, don't use NC flux. It's not gonna work. You're just gonna rip some pads. Even if you use really good wick, what you need to use is an RMA flux. RMA flux will burn in lower temperature. It's a lot more aggressive, so you do need to clean it. So don't use RMA flux once you put the new socket on. Don't use RMA flux because it will be very difficult to clean, and you do need to clean it. You cannot leave RMA flux on the board. That's why, for that reason, we use NC flux when we resolder the socket. So after this, if the board is prepped like this, all the pads are clean and there's no warping on the board and no moved capacitors, the board is ready for step 2, which is putting the new socket on and melting it in place. That is my least favorite thing to do. I don't mind taking the sockets off and I don't mind cleaning the board, although this is the most time-consuming part of it. But realigning the socket and melting it in place is very difficult. The difficulty comes mainly from the fact that you cannot really test it until you turn off the heat. When you remove the socket, you just lift the nozzle and you tap on it a little, see if it's starting to float, see if it's starting to move. Then you know you can lift it. But when you put the socket back on, you don't know if it already melted, if every single pin is melted. So you just kind of have to trust the process and rely on timer a little more than during desoldering. The thing to know about these sockets, these come from the Foxconn factory. These are the exact same sockets that are being put on the boards when the board leaves the factory, which means this is lead-free solder, which makes it especially challenging because the melting point is a lot higher compared to leaded solder, and the way it flows is completely different from how the leaded solder flows. So this is the most challenging part, putting the socket back on. So let's see if we can get this board into working condition. If it fails, we can always try again because the board is prepped. The worst thing that you can do, or the worst thing that can happen to you when working on this, is ripped pads. That means you were not patient enough. Usually that means you were not patient enough and you used force to lift the socket. A few pins were still soldered and they came off along with the socket. Second worst thing is when the temperature, you also perhaps lose your patience and you set the temperature too high. If that is the case, the board is going to warp slightly, which will result in the socket not sitting flush on the surface, which means it's not going to solder on correctly. After the socket is resoldered, there's no way to inspect the pins. There is one way that I found, which I do not recommend, but you could, each of those pins, right, is this the, yeah, I was just making sure I'm not using the new socket. Each of those pins you can lift. You can't really see it at this zoom level, but you can grab the pin and try to lift it. If it lifts, that means it's not soldered on. What can you do if it didn't solder on and you recognized one pin that did not solder on? I tried it. You could use the hot-air, use some good flux, and blow some hot air on it and push it into position. I was not successful in that. Basically, if the socket didn't solder on correctly, if at least one of the pins is loose, it's a failed job. Just take it as a failure. Don't try to fix it because you might break even more. Remove the socket and try again. As long as you haven't done any damage to the board, meaning no ripped pads and no and no warping, you can try as many times as you have to. So let's get the preheater set up, the nozzle, get the temperatures, get the thermal camera. One thing that I can recommend is what I use is a thermal camera to actually see the temperature. The board is usually ready around, it kind of depends on the board, but the board is ready when it reaches the temperature around 220 degrees and it's stable. That's when the solder usually melts, but it's very important to know that oftentimes or always it's a difference. The difference between the successful job and the failed job could be 30 seconds, not more than that. So you really need to be patient. As long as your temperatures are not too high, you can keep it for a bit too long and it'll be fine. It'll not cause any damage to the board. But if you're using higher temperature, which you still can do, but then timing is everything. That basically translates into temperature curve, how quickly the temperature rises. If you use low temperature, basically 260 that I use, that's gonna heat up the board to maybe 220 to 40 tops, but that's gonna take time. If you use higher temperature, the board is still gonna heat up to the proper temperature, but a lot quicker. And then if you leave the hot air still on, it's gonna melt your board. Basically, it's gonna warp your board, it's gonna overheat it. So you can use higher temperatures to speed up the process, but then you have no room for mistakes. You have to know exactly when to lift it and when to stop heating it. Luckily, the thermal camera gives us the ability to monitor the temperature. It's not too reliable because we still don't know the actual temperatures. Placing a thermocouple or a thermistor on the board would be a lot better, but that poses another problem because you need to measure very close to the socket. The heater needs to be right under the socket on this side, right? And also you don't want to lose any of these cups on the other side. That's another thing. But the heater needs to be in the center, dead center over here, very important. If it's shifted even slightly, then you might end up like I did with one of the boards, that one side of the socket was not hot enough, but the rest was perfectly melted. And I pulled it, and I pulled it along with 4 or 5 pods. Now, if it's 1, 2, or 3 pods, you're probably not even gonna feel it when you lift the socket. Since it's a lead-free solder, when you lift the socket initially, even when the solder is melted, it still gives you a little bit of resistance. The solder itself, just kind of holds the socket. So you still have to use slight tension to lift the socket, but then you don't know if you're not ripping the pads. So it's very important to just kind of catch that sweet spot, and that sweet spot is very narrow. All right, let's try it. Alrighty, so here we have it. The socket is replaced. It is aligned perfectly, because alignment was something that I was struggling with, but I concluded that if you have alignment issues on the socket, the pads are not clean enough. And if there's any solder on the pad, then obviously there's going to be a little bulge, which means you have to place the bolts on this side directly on the other bowl, right? And that is difficult, so the socket always escapes. So if you have alignment problems, it's probably the pads are not clean enough. Now, if you missed the details in the sped up footage, the preheating to about 130, 140 degrees, it takes 15 minutes on my preheater. As I said, I start with lower temperature, but that's how my controller works. So I need to start with lower temperature. And the main reason is because the thermocouple has a lot of thermal mass. So it takes a while for the thermocouple to heat up. That's why I start with lower temperature, and it overshoots by sometimes even 20 degrees. Because by the time the thermocouple reaches the temperature of the heater is already too hot. That's why I don't start with 260. Eventually I go to 260, so after about 10 minutes of heating on lower temperatures, I go to 260, then wait for the board to heat up, and start the 260 from the top, 266 to be exact. Now I put some NC flags on the socket and on the board with a little brush. So the initial, as soon as I turn on the heating from the top, there's plenty of smoke. Then the smoke subsides, and heating from the top another 15 minutes, so the whole process is half an hour. That obviously does not include prepping work. Prepping actually takes a lot longer, and it all depends on the tools you use. Now the socket is nice and solid. We don't know whether it's soldered on correctly, but based on my testing so far, this should be soldered on correctly. Now, is the board going to work? That is another question, because on this socket, I think there was only 1 or 2 pins that were broken. This was not a bad socket. I mean, it wasn't good, but it wasn't like awful, like 6 or 10 pins bent or broken, right? So, how the board reacted to that, it would turn on, the CPU would flash, would light up, the CPU LED, and it would turn off. That could be that the CPU was not detected, but not necessarily. This could be another issue with the board, but until we replace the socket, we are never sure, right? Because it could be just faulty socket, right? And if we can see the actual damage to the socket, then obviously that's the first thing that we should check, the first thing that we should address. So now hopefully the socket is soldered on correctly, and the best case scenario right now is that the board will just boot no problems. The other possibility is that it will turn on and off, in which case there's probably a Vcore issue or SA or IO. There's probably a voltage problem. However, since the board turns on and off, it's very difficult to actually find. So I'm not going to fix that. If that be the case, if this is going to be the behavior, turns on and off, I'm not going to fix it right away, because I need to locate hopefully the schematics for it. For some boards you can find it, for some you can't. And the board view. And again, for some boards you can find it, for some you cannot. If you need any board views or schematics or anything, hit me up on Discord. I've built a decent collection so far, and I'm still building more. So hit me up. I might have a schematic and I might have a board view. If not, Vinafix is a good source because they have a lot of stuff, but you do have to pay. And usually that is the case. The reliable service is going to cost you. By reliable, I mean the service that actually has some stuff. The best free source is Badcabs. That's what I use very often. And often I find board views over there. But sometimes it's not the exact same board. Sometimes it's not the exact same revision. So there are slight changes, slight differences. Sometimes it's even worse. It's even better if you don't have the schematic, or if you don't have the board view and you just try to figure it out yourself, rather than using board view that is slightly different and it's going to send you on the wild goose chase. Now we have memory, we have CPU, we have power. Well, moment of truth. The board flashed, that's correct. And Oh, we have the power button here. Oh, it doesn't turn on at all. It could be because of no battery. Let's see. I doubt it's no battery issue. But let's make sure. It's good enough. It's not new, but it's good enough. But it's very rarely that the board without battery won't boot. It's not typical. Yeah, it does flash. So SIO, you would expect SIO to be working. Yeah, it's the same thing. Although now it runs a little, yeah, now it reboots by itself. So it's different, right? But it's still not working. So is it the socket replacement issue? I don't know. Nothing points to it, meaning the visual. Nothing points to it. We have SA. We have IO. 3.3. 3.3 here. Let's check the memory. We have no memory. Oh, it could be it. However, it's weird that it shines CPU instead of... Let's see. Oh, there's no Vcore. Okay. So that's the issue. We have no Vcore. Okay, well, the socket had to be replaced on it anyways, right? With busted socket, it's, you know, it's crap. But we have no Vcore. The MOSFETs are not really heating up. Yeah, I don't feel them warming up at all, but that's normal. PCH warmed up, so PCH should be working. We know SIO is working because the board does turn on, but no Vcore explains why we have the CPU shining. Now, probably if I checked that before, we probably could have booted it, because if we fix Vcore, the board should boot because there was not an extensive damage to the socket. But the socket still needs to be replaced because it was busted. So we have something. We have missing Vcore, which is a great news because that should be easily fixable. Well, maybe not easily, but we'll see. I don't see the shorts. These are very unusual control MOSFETs. Let me show it to you. See those? So normally we see on these rails we see 2 or 6 transistors per coil, right? We need at least 2. Sometimes it's 6. Hang on, 2. No, 3. Yeah, not 6. What am I saying? 3 transistors per coil, and the low transistor is doubled. High transistor, we have 1 high transistor and 2 low transistors. But this one, as you can see, it uses dedicated modules. But if one of those modules was shorted, the PSU would have turned off. So this looks like the Vcore just doesn't turn on. And it might not turn on for multiple reasons. One being that the voltage is not correct and it goes to shutdown. The other reason, it doesn't get the enable signal for some reason, also some kind of fault detected, and the Vcore doesn't turn on. But let's see what we have here. Yeah, we have very low resistances here, but that's normal because the CPU is on. 7 ohms, 8 ohms on the coils. Right. We have 9 volts on SA. 33 ohms on IO. We do know that we get IO. The IO voltage is okay, and we have both IO 1 and 2. Both voltages are correct. On that other board that we still haven't figured out yet, we have only one IO voltage. We are missing the second one. I was thinking that maybe that is correct, but on this board we have both. So I'm thinking they both should be on as soon as the board turns on. Let's check here. 10 ohms, 12, 24, and 17. That's all good. So we have no shorts. So, problem with this board. First we need to find board view. Then we need to hopefully find a schematic, because that would help a lot. Because I'm not familiar with this circuitry here. These modules that are here. In addition, I'll look at it through a thermal camera, and we'll see if we can see any heat spots. But looks like the socket replacement was a success. Now we just need to fix the board. Alrighty, I think a socket replacement is something that, as I said at the beginning, something that differentiates a or maybe let me put it this way. Socket replacement is very challenging. It requires skill. It requires a lot of research. I have a full stack of boards that I broke, basically, trying to adjust the temperature. Melting sockets, melting boards, warping boards, ripping pads. So to get to this stage, where at least socket is soldered on, there were no ripped pads, there were no warping of the board, no missing components, no knocked off components. Even to get it to this stage, it takes a lot. That's why I was so keen on getting that actually figuring out the process to get that done. I was really keen on being able to do it, basically. But this is pretty much what the process looks like. Once you've done a few of these, it gets easier and easier with each try, because you just know what to expect and you learn your tools. Each tool is going to be different, so I would not advise to just try to replicate my process one-to-one, because most likely it's not going to work, because your tool is going to be slightly different. If that is something that you want to learn how to do, my advice is to get a stack of broken boards off eBay and just replace the sockets. Sockets can be acquired either on eBay, AliExpress, all kinds of sources. On eBay, it's kind of expensive, about 20-25 bucks, maybe 30 bucks per socket. So it's kind of expensive. But if you get it from AliExpress, it's going to be a lot cheaper. However, you do have to wait a while. Although on eBay, it's pretty much the same. It takes 2, maybe 3 weeks for the socket to get to you. Alrighty guys, I think that'll do. I'll look into why we don't have Vcore on this one, and I will update you on it. But this is socket replacement, my first fully successful socket replacement, meaning no alignment issues and no other issues. So it's only gonna get better from here. Thank you guys very much for watching. I do appreciate you, and I shall see you in the next one. Take care.